Okay, reminder, another example. Write the equation on a line that is perpendicular to this equation. Perpendicular lines have slopes that are opposite reciprocal. So the slope of that line is 1/2. The slope that's perpendicular to it would be -2. And through this point. So if we use this method, first we put 4 in for y, we put -2 in for m, and we put 6 in for x. Drop the rest of the stuff, then we solve that equation. We get -12 plus b on the right, and we add 12 to both sides, and we get b is 16. Then we take 16 and -2, and we put it back into here. So you get y equals -2 for m, x plus b, which is plus 16. Your final answer. Second version, using point slope form, y minus 4 equals -2, x minus 6, distribute. Add 4 to both sides. Same answer. Okay, and question 2 was kind of definitely non-routine. You really haven't seen much like that, specifically like that, but all the skills needed to do that problem have previously been available. Anyways, if measure of angle 2 is x plus 150. So then you're like, what the heck, how do I actually do this problem? Because 2 does not make a linear pair with this 90-degree angle. It doesn't. It makes a linear pair with this guy right here, just that part. So if we knew that one, we would be okay. But let's backtrack and see if we can figure anything else out based off of the picture. This angle right there is 132, so that whole angle forms a linear pair with 132. So if you do 180 minus 132, you get 48. Okay, you get 48 for that measure. And then if you look at it in terms of triangles, see this big triangle right there? You know what kind of triangle that is? It's an isosceles triangle. If that's an isosceles triangle, this guy right there is the other base angle, which means that's 48. Now, if you know that those two are 48, you also know that this, as pictured, was 90. 90 minus 48 is going to give you 42. So we get to there. And then we get that this whole angle right there, that's a straight angle, that makes a linear pair. So we get 42 plus x plus 150 equals 180. Since it's a linear pair, that is official. We can say that it is equal to 180. Combine like terms and solve. Minus 192 is just -12. We can get -12 for this because x wasn't the angle measure itself, it was just some value. Okay, negatives are okay. All right, next guy. If you did it the way I did it, I would do it. You would label the two. You draw a picture and label the two triangles. Label them in such a way that the parts match. So like A is bottom left, X is bottom left. B is top, Y is top. C is bottom right, Z is bottom right. Okay? After we do that, we label AB to be 38, BC to be 28, and XY to be 5X plus 8. And then we get a situation where we can actually set these guys 38 equals 5x plus 8 because these two are congruent, and those are congruent because they're in the same location in the congruent statement. This whole thing being a congruent statement again. When you solve that, you actually get that C is 6. We're asked for we get x as being 6. We're asked for the value of x, not the value of any of the sides, so we just leave it as 6. On this subsequent problem, it's an isosceles triangle. It's an isosceles triangle with vertex B. That means these two sides are congruent. Okay? And AC would then be there. AB 5x minus 28, AC being x plus 5, and BC being 2x plus 11. Now, it's an isosceles triangle. B was the vertex angle, so these two sides are the ones that are congruent. 5x minus 28 equals 2x plus 11. Solve it. 3x equals 39. X is 13. That's not our answer because our goal is to find the length of the base. The base of the isosceles triangle is this one. Is the one that's not a leg, or the one that's not congruent. So we stick that in there and we get C. Or B, being 18. All right, let's jump into the notes now. Let's jump into the notes, which is the other sheet that you have. Here we go. Okay. Previously in class, on the last episode, we talked about side, side, side. The exercise you did in class yesterday was you drew two triangles that had the same side measures. Okay? Then when you turned around and measured the angles, you noticed that all the angles were going to be the same, or very close to being the same. Okay? They should actually be the same, and that's actually what we're talking about. We talked about how to show that two triangles are congruent, we needed all 6 sets of things to be congruent. We needed all 3 sets of sides and all 3 sets of angles. We needed all 3 sets of sides and all 3 sets of angles. We said we would rather say that 3 sets were congruent rather than 6 total. So we whittled that down. One version of that was 3 sides congruent. So in two triangles whose corresponding sides are congruent, we can say that the triangles are congruent. Okay? If we have the 3 sets of sides being congruent in 2 different triangles, 3 sets of corresponding sides, which means matching ones when they're drawn. Okay? If those are congruent, then we can say that the whole triangles are congruent, which gives us that all 3 sets of angles are congruent for free. Okay? We also did one yesterday, or we were supposed to do one yesterday. The second set of what we were doing was that if we're in 2 triangles who have 2 sets of corresponding sides and the included angle congruent, we can say that the triangles are congruent. Okay. Which means if we have 2 triangles, okay, who have 2 sets of sides congruent, and the angle that's between those 2 sides, if those sets of angles are congruent, okay, then all of the rest of the parts in the triangles match, which means that all the angles and all the sides are all congruent. They all have the same measure. Remember, congruence meaning same size, same shape, same measure, same shape. Okay, let's get you just drawing some information and writing some congruent statements. So let's look at number 1 here. If we're to draw or to write a congruent statement based off the information I'm giving you, implying that the triangles are congruent. So to do that, if you follow the directions here, we're given the information that segment AC is congruent to segment NO. So segment AC right here from one triangle, congruent to segment NO from the other triangle. Okay, that's what that tally marks means. Okay, and we're given information that segment CL from one triangle, so let's draw CL in there. I'm just throwing it out there that it's going to be there. CL congruent to segment OP from the other triangle, 2 tally marks. Okay, and we have this triangle now. Also, we're given a situation where angle C is congruent to angle O. Notice how we have a side angle side situation, a SAS situation where we have 2 sides, 2 sets of sides, 2 sets of sides and their included angle, the angle that's in between them, being congruent. That's a side angle side situation. We did that yesterday in our activity, measured that these 2 angles are actually, or these, if we have a side, an angle, and a side, that those 2 triangles are actually in fact congruent. The question is, write the congruent statement that say that those two triangles are congruent. The congruent statement meaning we line up the angles that match. Which angle matches? Let's start with the easy one. Which one matches with C from the other triangle? Which angle? O, right? Okay, let's pick L. Which one matches with L? P, because the way we drew it, they were in the correct order. It's the way we drew it. Another way to view it is that L has the side length with 2 tallies and the side length with none. P has the side length with 2 tallies and the side length with none. And then A would be the last one, and N. Notice how the congruent statement matches exactly what the triangles are, which vertices match which vertices in the triangle. Let's do it a second time. Let's do 4. If we draw it, we draw HY. We want that to be congruent to RP. So we're going to draw them about the same size, in the same shape, in the same direction. Okay? We want EY, well, Y is there, so E's got to be down here. Congruent to AP, P is there, so A has to be like here. And then, since they're triangles, and then Y congruent to P. We have another side angle side situation where we have 2 sides and an angle that's in between them. The angle that's straddled by it, by the 2 sides. So our congruent statement, if we start with angle Y and angle P, just because those are already given to be the same. If we go to the bottom right, E would then match with A. E was 2 tally marks and nothing. A would be 2 tally marks and nothing. And then H, and then R. Any questions on those? Okay, let's take a look at the next questions. The next questions say, now, can we in fact show that these triangles in this picture are congruent based off of the information that we're given in the picture? Here's the situation, guys. We only have 2 ways to show that triangles are, 3 ways to show that triangles are congruent. We have an SSS situation, we have an SSA situation, and a SAS, okay? Or we have all 6 pairs, right? We have the third one that's all 6 pairs, but why would you do all 6 pairs, right? Because we have those 2 other ones. So really we're just going to wind up using these 2, okay? Do we have that situation drawn out here? Do we have a side angle side or a side 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 situation? Let's take a look. Well, AB is marked with 1 tally mark. BS or BC is marked with 1 tally mark, so those 2 sides match. I'll label them with an S. You notice the double tally mark right there? That's shared between the triangle on the right and the left, so that matches. With me? Do you see the angle that's marked? This is 90 right there. That right there has to be 90 based off of the theorems we talked about last chapter, or last unit. So we have an A there. Do you see how we have a SAS situation on both? We have a double A together. We have a double S. Right? SAS and SAS. Okay? SAS and SAS. So, yes, these are congruent. Why are they congruent by SAS? And what's the congruent statement? These directions, guys, ask us for 3 different things. Are they, if you read the directions, are the triangles congruent? If they are, explain your reasoning. SAS is our reasoning. Okay? If they are congruent, and you've explained your reasoning, give me the congruent statement from that. So, I'm going to erase all the scratch mark so we can see it a little bit clearer. If you have difficulty also, what you could do is draw the 2 triangles next to each other. You know, just, oh, that's D. That had 2 marks. That had 1 mark, and this was 90, and that we ended up saying 90. You see the SAS situation as well, when they're separated? A, which matches with A matches with C. B matches with B, and D with D. Question for you guys. Can you see that this is just a reflection over this red line? Okay? That's why we did this stuff earlier, this unit. The rotations and the reflections and stuff. That shows, that's another way to show that two triangles are congruent based off of those rigid transformations we call them. Okay? Because it's just like it's reflected. Two triangles being congruent, it's the exact same thing, just copied. How about an 8? What does 8 look like? Does 8 look, if they're congruent, okay, are they congruent first? By SAS or by SAS or side? Right there we have a side that matches, right? What else is marked? Right here we have 2 tally marks right there. Those match. Do we have a third set? 3s and 3s. How many sets of sides? 3 sets of sides. It means all the sides are paired up. That's a yes, they're congruent by. Okay? Do you guys see what transformation it is from the left triangle to the right triangle? If I go from the left one to the right one, what happens to it to get it to go to the right?
Rotates.
It rotates to the right, actually, clockwise. Right? A turns into W, E turns into D, and R turns into F.
Sure.
Can you see that? Yes, sir. Okay. Also notice when we write our congruent statement, do y'all see that A has 1 tally and 2 tallies that border it? If we write A first, so then we look at the other triangle looking for 1 tally and 2 tallies. That's W that shares the 1 tally and 2. Right? E does 1 and 3. D is 1 and 3. R is 3 and 2. G is 3 and 2. Tallies that border it. Okay? Can you see one of the transformations on 9 between the 2 triangles? Which one is that? It's a reflection over this line. You guys see that there's a reflection over that line? Notice how we have an S and an S there, side and a side. Notice how we have the angle that's in between those 2 sets of sides that are also marked. We have another set of sides. See how the angle is squeezed between those 2 sides? It shares those 2 sides. The angle is made up of those 2 sides. That's what we mean by an included angle. That's a SAS, yes, congruent by SAS. And then we need to write a congruent statement. Since it's reflected over that red line, H matches with H. G matches with, G is marked with 1 arc, I is marked with 1 arc, so those have to be true. E and J. Okay?
Sure.
Let's go to the bottom. I want you to do 2 problems. We'll go over them before you leave. Okay? I want you to do 13 and 15. Right now, I'll give you like 2 minutes. If you do it the way I do it, you're going to label the picture. So please do it the way you are. Wait. Just do it the way I do it. Label the pictures as you do it. Here we go. 3, 2, 1. If you do it the way I do it, you label it R and M, or L and M match, LD and MR match, LO and MA match. Is that a SAS situation? Is that angle between those 2 sides? That's a SAS situation. Yes. The angle is in between the 2 sides. With me on that?
Yeah.
The next one is going to be a no, because the angle's not between the 2 sides. Let me show you. LD, MR, LO, MA, O, and A. Do you guys see how that angle's not in between those 2 sides? It's a side, and an angle, or it's an angle, a side, and a side, But we can't, this one's a no.